Hello friends, so today we shall talk about how to add two vectors. Suppose you have a vector A like this and another vector B like this. So the resultant of A and B or the addition of A and B can be drawn like this. Okay, let me give it a name C. So using triangle law we can write C equals to A plus B. But like any other algebraic calculation, we cannot just add the magnitudes of A and B. The calculation for C is a bit different. So let us try and calculate what will be the magnitude of C in terms of A and B. In order to do that, first we have to know what is the angle between A and B. So let me just remove this C for now, and what we will do is we will shift this B parallel to itself to the origin of A. Okay, now the angle that is formed here, theta, is called the angle between A and B. The next step is to draw a parallelogram like this. Fine. Now if we draw the C has now become the diagonal of this new parallelogram. Okay. Now we'll try and calculate what is the magnitude of C in terms of A, B and theta. So for that purpose, let us elongate a little bit and drop a perpendicular like this. So now as you can see, this triangle, okay, this is the right angle triangle. Fine. Now if you can use your basic geometric thoughts, you will see this is theta as well. Fine. Using the right angle triangle property and this angle theta, we can write this elongated part equals to b cos theta, and this perpendicular will be b sin theta. You can use your trigonometric knowledge and the properties of right angle triangle. Using trigonometry, you can find the base to be b cos theta and the perpendicular to be b sin theta. Okay, now this entire triangle, that is also a right angle triangle, right? So using again the property of right angle triangle, we will use the Pythagoras theorem. Using the Pythagoras theorem, we can write c square equals to a plus b cos theta, which is the total base of the new right angle triangle, whole square of that, plus b sin theta whole square. Okay. After this, we can write c square as a square plus 2ab cos theta plus b square cos square theta plus b square sin square theta. Now these two terms, if we take b square outside, we will get sin square theta plus cos square theta in the parenthesis. So this will just become a square plus 2ab cos theta plus b square. Simply this. So what will be the magnitude of the resultant? C equals to root over a square plus b square plus 2ab cos theta. So this is the magnitude that we were looking for. So now vector subtraction is not so very different from vector addition. Okay, so in order to do vector subtraction, let me first remove this calculation first. So for vector subtraction, let's say we want to do a minus b. Alright, so we can write this as a plus of minus b. That means we can just change the direction of this vector b like this. So this is my minus b right now. Okay, now the angle between a and minus b is this, which is basically 180 degree minus theta. So the formula that we had, which was c square equals to a square plus b square plus 2ab cos theta, that was for vector addition of a and b. Okay, so let me remove this square, then it will become c equals to root over of this. So now if you want to do a minus b, what you have to do for the calculation is just put minus b instead of b. So here if you can see, the b square term is there. So if you put minus b in terms of b, it will remain b square. but if you put minus b over here, the equation will change. So let me write this as c prime, which will basically now be a square plus b square minus 2ab cos theta. So c prime is what? It's just a minus b. Okay, magnitude of a minus b. Fine. So how do I draw this c prime? So c prime can be drawn in this parallelogram like this. Let me elongate this side and connect it like this. So c prime is here this side. Okay, so that is the subtraction of vectors. These two things are very similar, addition and subtraction. They are not very different from each other. We can treat these two things as same. You just have to remember, when you do subtraction, this minus b, we can write the minus b as plus of minus b. Okay, and we can follow the same rule as vector addition. In order to derive this properly like we did for vector addition, we can again do this sort of calculation. Make a right angle triangle, take the angle 180 minus theta as the angle of this new right angle triangle. So we'll not go into that there's so much of calculation, but I hope you get what I'm trying to say over here. So these are the two formulas for vector addition and subtraction. So here one thing may bother you, that why I did not change theta to 180 minus theta. So in the expression of C, if you do cos 180 minus theta, you will get a minus cos theta. And this change of theta to 180 minus theta includes the change of the sign of B. If you do both, I mean if you do change the theta to 180 minus theta and if you change B to minus B, all you are doing is reverting back to vector addition of A and B. Okay, so either you change the sign of B to minus B, or you just change the theta to 180 minus theta. You do either one of those. Okay, don't do both. That will just revert back to vector addition. I hope you understand that. So let us proceed to do some further problems.